Okay, I'm going to go over the problems that we've been looking at the last 2 days in class. Some of these we did, but I figure it doesn't hurt to have the video so that you can reference back. So, first problem, we've got a block. It has a mass of 2 kilograms sliding on a 25-degree inclined plane. So we've got an incline here at a 25-degree angle to the horizontal. We're given coefficients of both static and kinetic friction, and we want to know acceleration. We're told that this block is sliding, so we know that it's moving, okay? So we're going to use the coefficient of kinetic friction here. And we want acceleration, so we're going to go through and get our components, our F net, and then finally our acceleration. So we're going to remind ourselves when we're on the inclined plane, we've got a force of gravity straight down. We have a normal force that's perpendicular to our incline. We're going to have components of this force of gravity. We're going to have a y component, and we're going to have an x component, okay? And then we're going to have friction because we're told we've got mu values, so we know there's friction. Friction's going to be in the opposite direction of our motion, okay? It's not very clear. Okay, so we've got an FGX and an FGY. Remember, we're using this angle here and this tiny triangle, okay? So FG, the X component, is going to be our force of gravity, our unresolved vector that points straight down, times our sine of our angle. Our angle here is 25 degrees. Our FGY component is going to be FG times the cosine of 25 degrees. And that is also equal to our normal force, because that's the force that offsets normal. Because remember, this is tilted. Like this is our x-axis, this is our y-axis. So in a y-axis perspective, my block's not moving up and down. It's balanced. So that means that normal and FGY are equal to each other, okay? So we can go ahead and calculate some numbers because we've got our mass here. So we've got 9.8 times 2 times the sine of 25 gives me 8.28 for my FGX. And then same 2 times 9.8 times cosine of 25 gives me 17.76 for my FGY and my normal force. And then I'm going to use this coefficient of kinetic friction, since we're moving, to get my force of friction. So I'm going to have 0.3 times 17.76. That gives me 5.33. My net force is going to be my movement along this x-axis. So that's going to be FGX minus FF. This is my positive direction, my downward direction, down the incline, because that's the direction I'm moving in. And then friction is like opposing that, okay? So that's going to give me 8.28 minus 5.33 equals 2.95. And then my final step is going to be to calculate acceleration. And that's going to be my F net divided by mass. Remember, that's just the same as F net equals mass times acceleration. We're just solving for acceleration. So we're going to have 2.95 newtons divided by 2 kilograms. And that's going to give me 2.95 divided by 2. That's going to give me right at 1.5 meters per second per second. Okay, so my answer is A, 1.5. Okay, number 2, we did this one in class. I think I did this in both classes, but again, just so you have it here. We've got a mass that's suspended from 2 strings. So we've got one string that's a T2 tension that's horizontal. And then we've got another one that's a T1 and it's at an angle. It's at an angle of 30 degrees. So that means this angle is also going to be 30 degrees. And we know our mass is 20.4 kilograms. We're going to have a force of gravity pointing straight down. We're suspended, so we're not moving. Okay, so our forces are balanced. Okay. And we want to find T2. So we want to find this. Okay. So let's start off by figuring out what our balanced forces are. So our force of gravity is going to be balanced by the y component of this T1. So this T1 is at an angle. We're going to have to resolve it into 2 components, an x and a y. We always have to do that if we're at an angle because we need everything to be either in an x or y position or direction. Okay. So this is going to be T1y. We've got T1x here. So force of gravity is balanced by T1y. And then our T2, this horizontal piece, is balanced by T1x, the x piece on the other side. Okay. And I can get my force of gravity because I'm given a mass. So I've got 20.4 times 9.8 here is right at 200. I'm just going to go ahead and round that to 200. So T1y equals 200. So then I can actually use this to help me figure out what T1 is, okay? Because if I know T1y is 200, I also know that the sine of 30 equals T1y over T1, okay? So let me write that. Sine of 30 equals T1y over T1. So if I switch these around, solve that for T1, that's going to be T1y divided by sine 30, which equals 200 newtons, because that's balanced by my force of gravity. So those are the same value, divided by sine of 30. And I got 400 newtons when I did that. So now that gives me my T1 value, and that means I can use that value, that's my hypotenuse basically of this triangle, and this angle to help me get this piece. And then I know that this T1x piece is the same as this T2, so that'll give me what I need. So my last step is to take T1x equals T1 times cosine 30. So that's just saying this side here, okay? This side is equal to I'm using cosine of 30 equals adjacent over hypotenuse. That's really what this is. And then I'm shifting for this side that I need. So this is 400 times cosine of 30. And when I multiply that out, I get 346 newtons. And that is the same as my T2. So that's my answer. So 346 newtons. Okay, last one for this video. I'm trying to keep these to roughly 10 minutes. This is another one I did in class, I think with both classes, but I have a girl pushing a box. There's an applied force of 50 newtons. There's a force of friction of 45 newtons. And I want to get time that it took to get to a final velocity of 2 meters per second. So I'm going to be using forces here. I'm also going to be using kinematics. So let's start by just getting our F net and our acceleration because we know we're going to need those. F net's going to be my applied minus my friction. So that's going to be 5 newtons because I've got 50 this way, 45 this way. That's my difference. acceleration is going to be that 5 newtons divided by 10 kilograms. That's my mass. So that's going to give me 0.5 meters per second per second. So now let's think about this from a kinematics perspective. I have an acceleration value. The box accelerates from rest, okay? So that means I have an initial velocity of 0 to a final velocity of 2 meters per second. So I've got acceleration, I've got initial and final velocities, and I need time. That's what I want to solve for, is time. So thinking back through my equations, this one's really going to be the easiest to use. Because here I don't have any information on, nor do I care about displacement. So I'm going to fill in quantities here. 2 equals 0 plus 0.5 times t. And then I'm going to solve that for t. I'm really just dividing 2 by 0.5, or dividing both sides by 0.5, and I end up with t is 4 seconds. So that's how I got that one. Basically getting my F-net and my acceleration first, which is what we've been doing with forces, and then combining that with the kinematics equation. So, okay, so that's 1 through 3, and I will see you in the next video.